Hi folks, welcome to everyone. In this video I am going to perform a quick setup of my PCB board with the Embassy framework. I will show you my PCB board in a moment, but first let's say some words about Embassy. It gives support to many hardware abstraction layers for different manufacturers. So you can pick a different board if you don't have yet one, or you can check which ones are supported before. There is no register manipulations needed. All of these comes implemented. It offers its own async await for multitasking instead of RTOS, TCP, UDP and more. And of course it has all the advantages of Rust. So today I will run the typical example, blinking a LED, and troubleshoot some of the errors that you might find at the first. This is my microcontroller. It is the model STM32 F103RB. This one has 64 pins on it and an ARM CORTEX M3. But it doesn't matter for this tutorial. Nucleo 64 board comes with the ST-Link interface. Here it is on top for communicating with the board. It is a separate microcontroller that does that job. I will plug it to the computer now so you can see how the power LED turned on. When there is data going through it, the LED will blink. It has two buttons, the user and the reset button. The LEDs LD3 and LD2, which is the one that I want to blink today. And on the other side of the board, you can check the model name of the board. I have already downloaded the datasheet for it. But if you have a different one, just go on the internet and search for it. And I also opened the project folder. I navigated to the folder corresponding to my device, and if you have a different device, make sure to choose the right folder, or otherwise you can just adapt to it. To just build the Blinky program is easy, but in order to flash the binary into the device and debug from the PC, it has to communicate with the board. So first of all, we need to check out that the ST-Link shows up in the USB devices. So let's see if the board is recognized by the computer. It works, and check out these IDs. We will need them later to set up the permissions. These IDs belong to the vendor ID and product ID. Luckily for us, there is a tool called probe.rs tool, and the Embassy framework uses this tool. So you need to install it and we'll make everything work. This is to debug and to flash in the device. I had installed already, and now we will try to print the info about the device to find out whether the communication is working or not. And you see we have no permissions. In Linux, we have to navigate into this folder and there set a bunch of rules that enables a specific device to be granted at user level. So you don't need to use sudo all the time to grant permissions. In this case, I downloaded it from the internet, but if you need to set this file and cannot find it, just use the same kind of boilerplate that is here, or create a copy from another one that you have there, and just edit the vendor ID and the product ID. Now we need to reload the rules. And now we should have access. You see there is an error during the access. When we get this protocol error, in my experience, is because I have to press the reset button. Somehow the CPU is busy running the program and it doesn't accept the connection request. This is the feeling I have, and sometimes I need to reset it twice and it works. Now the command works and we can obtain the info from the device. So we are ready to flash it, to flash the program, but before we will need to do some adaptations in the code. I have opened the examples folder of the STM32F1 in VS Code. In the cargo tolm file we have the dependencies, Rust crates or libraries that are needed. I will just update this one, which is deprecated. We need to adapt the chip name in the config to match the specific one that I have, and therefore the pin number of the LED might differ. So I can tell you in advance that at first it is not going to work, most likely. So the LED maybe won't blink. Then we will have to adapt the pin number in that case. Notice how the probe RS tool is set there in the runner parameter, so that way when we run cargo, the cargo command, it will directly use this tool for flashing. The -- being it is to specify the name of the binary that we want to build, which matches with the file name, right? blinky.rs. So this is how the compiler scripts know which example I want to run, because all the examples are on the same folder. And the -q to make it quiet. There is an error because I have to press the reset button again. Build again. Yeah, we see how the program is running. The power LED blinks, so there is communication going on. But as I said, it is not working. The program is running, but the LD LED is not blinking. We have to adapt the code to set the right GPIO. Looking at the code example, we are currently setting GPIO PC13. This is how it worked, perhaps with the original chip that was set there. And LED is holding the address to the wrong register, although the structure is called output here, but under the hood you know that it has to refer to some physical address, right? And maybe the LED variable should be called user LED, but it doesn't matter right now. So I will look at the backside of the board. In the board's datasheet, and here you can find how the user LED LD2 is connected to pin 21, solder bridge 21, and on the microcontroller datasheet, the pinout information tells us that 21 is named as GPIO PA5. So let's change that in the code. I will stop first the execution, that it is still running. Currently it is switching the wrong pin. Replace it to PA5, so it will switch the right register. Now you see the error, so we need to press again the reset button. And now it works. So such an amazing framework, guys, that allows us to quickly set up the environment to start programming. And on the next video I might go and do something different, but I plan to continue recording some videos about Embassy or embedded Rust, and I will talk about some tools and tricks that you can use for debugging and combine them with Embassy. Ciao!